Hello, everybody. Hello, folks. Good afternoon to you. Okay, let's continue. Today it's our first day, our first session of our training course. So today we will talk about advanced features. Okay, and our summary for today is we will talk about USB port, mass storage device, Wi-Fi adapters, 3G, 4G modem device, and converters, USB to serial, RS-232. We will talk a little bit about our data logger library and with an example. And we will finish these sessions with the PID loop controller and some process simulation here with the Express that I have in my hands, okay? Okay, USB porting next to Express. Well, the USB port presented on next to Express is a host type. It allows that controller to extend its functionalities by using several types of third-party USB device. Due to the wide range of USB device available on the market, flash drives, Ethernet, Wi-Fi adapters, and 3G, 4G modems. The support for each specific device is usually provided by a firmware update. So here is the USB port and the USB LED here. So we support mass storage device, Wi-Fi adapters, modem device, and the converters USB to RS-232. Well, the first device is mass storage that we'll talk. Mass storage device can be used to expand the internal controller's memory flash memory to store large amount of data, like on data loggers applications, for instance. To use a USB mass storage device, simply connect it to the USB port. After a few seconds, when the device is properly detected and mounted, the USB LED will turn on. The device information will appear on section USB device located at the tab PLC Management of the Controller's Diagnostics webpage, as I will present to you. After the device is properly detected and mounted, a new folder called Mass Storage will appear on the controller's memory in Master2 software, and I will present this to you. So I will connect now the USB here, and let me just open our diagnostic page here. Here, USB device, mass storage connected. And I will open this, admin, the default username, admin. And you can see here the information about my device. I have a special files inside. It's don't boot app. If I power on the Express with the USB connected, this message, and this file inside at the root, the app will not be loaded. So I can eject. Another point I can show you, it's this. Here it's the master tool. And I have here the files. I will update it. And you can see here, here is the Express. And here is my computer. So I can see that I have a folder with data logger. This file, it's the same file that you saw here, download app. So I can see every file that I have in my USB. To eject this, let me just return. I will eject this folder. And you will see here that the USB device, it's not found. Okay, continues here. This one, yep. So here I have the diagnostics web page and the controller's memory that we saw. USB port mass storage device uses examples, data logger, store source core, programs, store project related data, such as CAD designs, manuals, documentation, bypass, normal controller application launch for troubleshooting, for example, and copy an application to internal control memory. So we can load a project just using the USB. Next one, it's the support for 3G and 4G modem and Wi-Fi adapter. The features allow that Next to Express PLCs to be connected to a wireless, corporate or mobile networks. These features allows, for example, the controller to use the 3G, 4G network available in the region, transmit data from remote units, process or machines, for example, far from the control centers without need for a dedicated physical structure. Usage examples, IoT, Industry 4.0, MQTT protocol, we can send information as you saw in the last session that we had. Remote access, so I can programming using this port through master tool software, programming, monitoring, updating. Visualization of embedded SCADA HMI scripts via web server. As we saw last session, last week, you connected to the web visu that I created inside my Express here. So Wi-Fi adapters. An USB Wi-Fi adapter can be used to connect a PLC to an existing Wi-Fi network, creating a second network adapter that can be used for programming and communication. The following tables shows the listed of support chipsets. So we have this table, we can use the Realtek, this chipset model, and MediaTek, this chipset available. So the link, this is the model, commercial products, of course, the name, and the Qualcomm TP-Link model TL-N721N. This is exactly what I have here in my hands. So what I will do is connect here. Let me just change to this. You can see here that it's not found. So I'm waiting. Okay. Let me just update this. So here you can see the USB device, Wi-Fi adapter, and to connect to the network, we use the management tab here with the same. So here you can see that this Wi-Fi that I have in my hands here. It's connected. The IP address, it's in my network here. So the IP address, the MAC address, and this is the configuration. So here I can scan networks that is closing to me and just configure this Wi-Fi adapter using this web page. So just using the diagnostics here. This is my network here, and here all networks that this adapter found close to them, to the next that I'm using. Of course, here I will reopen this. You can see here at, for example, special system diagnostics here. I'm connected, and I'm connected using the cable. Now we can see this here. I'm connecting using the cable, not using the Wi-Fi adapter. But you can see here in the detail, USB. Here you can see that it's connected a Wi-Fi adapter. Before it was connected here a USB device, because the same information that we have here, we can check inside the master tool. So I will open the Wi-Fi adapter here, and you can see that I'm connected. The IP, it's the same IP, 24, the final, 24, and the MAC address here, the final 7E, 7E. So I can check this, and for example, now I will log out, and I will connect using the USB. To check my connection that I'm using the Wi-Fi dongle here, I will reopen this just to show you Ethernet, net 1. You can see here that the link down is false. So I will disconnect, and you can see that the link down from my network connection, it's true again. So it shows me that I'm connecting using the Wi-Fi. I will reconnect here. You can see false again. And I log out to connect again using the Ethernet port, the physical Ethernet port. Okay. Here I have a timeout, of course, because I disconnected. So I need to. And just as an example, I will connect the diagnostic page using the Wi-Fi adapter now. So the IP 0.24, it's connected, and the IP 7.7, it's connected, the physical and the Wi-Fi. Okay. Now I will return here. The management of the Wi-Fi adapter's functionality is done through the USB device page in the PLC, as I'm shown, of the controller system web page. Once the Wi-Fi adapter device is properly detected and mounted, the USB LED will turn on, and the device information will appear as will be presented in the diagnostics web server and master tool. So exactly what we saw. Okay, modem device. An USB modem with a SIM chip can be used to the Just wait a second. Okay. Okay. Just to inform you that the list of these chipsets, it's in constant revisions. This one, let me just, this one, and this one. You can check the revision of these chipsets in our data sheets of the product. Every information that that you are seeing here, it's available in user manual and the data sheet of the product. Modem device. An USB modem with a SIM chip can be used to connect the PLC to the internet using the mobile data network. Telephone service like sending SMS or calling numbers are not implemented. So just an observation about this. These features allows to use Nexto Express controllers to implement telemetry and IoT applications. There are basically two types of modems, the bridge and router. The following table shows the list of supported devices. Here we have basically the same manufacturer, Huawei, and these models. The management of the USB modem functionality is done through the USB device page in the PLC management tab of the controller system web page. Once the modem device is properly detected and mounted, the USB LED will turn on and the device information will appear as will be presented in diagnostics web server and master tool. So I will return here. I'm connecting to the cable here in the master tool. And you can see that I'm using the Wi-Fi adapter. So I will disconnect the Wi-Fi adapter here. Okay, USB not found. And now I will connect the router. I have this router with me. And I will connect here. It takes a little bit of time because the router is restarting here. And okay, it seems that's okay. Let me just update the page. Yeah. USB device modem. I'm connected now. Again, USB. So here it's configured, and this is the IP address from my modem here. So I can connect the same way using the master tool. Let me pass here, the master tool, just to check the information about the system diagnostics here. T detail, USB, modem device connected and found here. And here is the IP of my modem, 9343, 9343. Okay, so to connect this, I will copy this. Oh, sorry. Let me just copy here. And here at master tool, what I need to do to connect the master tool service to this modem, it's create actually a gateway number 2 with this, actually not this, but this 187. 187.91, 91.93.43. At this port, because it's the port that we will receive the project. And you can see here the gateway is running. And when I double click, I found an express there. So I will connect these and I will log in using my wireless, my internet connection here from my computer to find the connection in master2. And here I'm connected now. Again, to check this connection using this gateway, you can see here Ethernet network. The link down is false. I will disconnect here, and it's true now. To check, of course, I have a problem here because I disconnected at this port, but what I will do, it's this. Returning to the device, copy this, and paste here. So I'm access the web here, and I will share this with you. And if you want, you can connect. Let me just find the chat. Oh, here. Chat. Everyone. If you connect this, you will see the page of my Express. I will let this connected, so I have no problem. And you can access exactly my device here. Okay. So I'll present the web server and master2, and you can connect, of course. If I don't have any web server web page embedded now, but if I have, we can just access using the USB. The fourth one, connection that is available, it's USB to RS-232 converters. I don't have any one of these devices with me, so to test now, but you can connect it. Next to Express, allow to implement an RS-232 port using the USB to serial converters. These converters are based on an internal controller chip. The following table show the list of these supported controllers: FTDI and Prolific. It's the manufacturers of these converters that we have available, the drivers inside the Express. This port is intended to be used exclusively with the serial communication function blocks provided by the next to serial library. This is very, very important to say. We cannot connect, for example, a Modbus at this port, just the library to exchange information using the serial. Allowing to implement a point-to-point communication with equipment that uses simple protocols, non-time critical, like radio modems, barcode readers, RFID readers, and so on. Additionally, this kind of solution has the following limitations. The baud rate, values lower than 40,800 bps are not supported. Data bits, value 5 is not supported, only 6, 7, and 8. Parity, values mark and space are not supported, only odd, even, and none. And stop bits, value 1.5 is not supported, only 1 or 2. After plugging the converter into the USB port, the USB LED may turn on, indicating that the device was properly detected and mounted, and the device information will appear on section USB devices located at the tab PLC Management of the controller's diagnostic web page, as shown below. Okay. Any question about the USB port? Okay. Keep going. Let's talk a little bit about data logger.
Yeah, I have one question here.
Okay.
Yeah. This is directly connected to the PLC, right?
Right. Mm-hmm.
And connecting to what? What is the other side? Is connecting to the SCADA system or connecting to other external systems?
You mean the USB RS-232 or
Yes, in general, the USB that or the Huawei modems or the one is related to the transformation between USB and RS. What is how we connect to the PLC? This is enabling connecting to PLC directly, and how we get the data, or what? I'm just confused about this, and if this something security wise accepted or not.
okay. Uh, if I understood well, we are talking about the just about the RS-232 converters, right?
No,
Or
the
every.
previous everyone. Yeah.
Oh, okay, okay. So actually, okay. Let's talk a little bit about the Wi-Fi adapters. This is just
What is the use case on this? Yeah, I just want to understand what is the use case of having this function or this enablement feature. Yeah. From your
Mhm,
point of view, of course, or from
mhm.
Altos point.
For example, Wi-Fi adapters. It's a very, very useful tool, for example, for building automation. When you don't have to, for example, you installed an Express to control, for example, air conditioning, heating, lighting, and you don't have infrastructure cable to connect to the Express, but you have a wireless protected with password and whole cybersecurity in your wireless infrastructure. So we can use this wireless infrastructure to connect the PLC that is, for example, controlling the elevators, water from the building automation. The modem device, we have some applications that, for example, we can connect using here we are using in some trucks. We can put this Express to scan information about it, and just digitalization information about some trucks, and to sending this information using the MQTT. uh, we can use the 4G network that we have available in the city to send this information to, for example, a central control and operation room, for example, from these trucks. We are doing this here. Another point, another application about the USB modems. It's we talked, I think, last session, connecting to the some small boats close to a city. Of course, if I have a small boats in rivers close to a city that has these 4G signals from cellular phone, we can collect information about these small boats, send this information again using the MQTT functionality that is available, and we saw last week. Or, for example, control exactly what we did last week using the web server embedded. So you can controlling, for example, from your place here or any place in the world, just knowing the IP, and you can connect it as so. This is the main functionality from the Wi-Fi and the USB modem device. Of course, for the RS-232 here, it's this kind of this kind of device that we can connect. For example, radio modems, barcode readers. So it's just a protocol point-to-point, as we talk here, implemented a point-to-point, and we use the next to library, the next to serial library to connect this. So of course I need to know exactly how the other device can connect to my USB converters here to 232, and I can read information from these RFID readers or barcode readers, or exchange information using the radio modems. And of course, the mass storage, just to allow us to expand our memory to send information exactly using a data logger or copy an application to internal controlling memory. I think this is the main functionality of this of this feature, actually. Did I answer your question?
Yes, thank you.
Okay, thank you. One point information about cybersecurity and modem device. It's exactly, for example, when you were using, here I'm using a router, and I need to open the doors with safety, of course, that can connect, for example, the port from the web server, it's 8080, and the port of the diagnostic page is 80. So of course I need to prepare the router to receive information and exchange information using these ports. Okay. Okay. Any other question about the USB ports? Nope. Okay. Keep moving here. Let's talk a little bit about the data logger library. So the data logger library, it's a library that makes available one function block, the data logger, of course. This function block data logger allows the user to record data in an organized way in CSV files stored in non-volatile memory. So they can be visualized thereafter in spreadsheets applications like the Excel. The CSV files created by the function block can be stored in the following types of non-volatile media. The internal flash memory that we have in all models of Next to PLCs and Next and Express, the modular and the compact one, and Xtorm's RTUs, our RTU. Memory cards. We have the memory card functionality just in our modular Next to and the Xtorms. and the USB flash drive, just in ExtraExpress. The functional block, it's exactly like this. So here we have some information to configure and some outputs to check how is the functionality and if it's working well or as expected. We have here, I cut to put here, but the input, we can put 256 inputs in my data logger. So the main part is here, and here we can put these several inputs, okay? Some main configuration points here. We need to insert a file name, prefix for naming folders and CSV files. This input defines the prefix used for CSV files, main CSV files, and of course, the folder that will be created. Storage, type of non-volatile storage. This input defines the type of the non-volatile storage where the CSV files are saved in PLC. Internal memory, memory card, and USB mass storage, as we saw. File records, the maximum number of records in a CSV file in continuous mode. This input defines how many records can be stored in a CSV file in continuous mode. The range can be from 100 to more than 6,000. Number of files. Maximum number of CSV files per folder. This input defines how many CSV files can be saved inside a folder by an instance of data or functional block data logger. One choose a non-circular storage of files. Circular storage of files. This input defines if the storage of files is circular, replacing oldest files, or non-circular, stopping registering new files. So here we will see an example for us, circular later, to understand a little bit more about this. The mode. We have basically two modes. This input defines the operation mode of the functional block data logger and can be continuous mode. In continuous mode, the selected input values are recorded cyclically. The cycle for each record is defined by input parameter rec interval. When the number of records in CSV file reaches input parameters file records, this CSV file is closed and a new CSV file is opened with the next sequential number. Trigger mode. In the trigger mode, the selected input are recorded according to a trigger condition defined by input parameter called trigger. In each rising edge of trigger input, one CSV file is normally created, and the number of the records of this file depends on input trigger before and trigger after. Basically, this mode is just to collect a fault and what is the variables in a pre-fault mode and post-fault mode. So trigger before, I can see the information before my fault or my alarm or something, some event, and these variables after this trigger. The trigger before, number of records before trigger, this input defines how many records are saved in a CSV file before rising edge of trigger input. This input is not considered in continuous mode. Trigger after, number of records after trigger. This input defines how many records are saved in a CSV file after rising edge of trigger input in trigger mode. This input is not considered in continuous mode. Trigger event. This is exactly the rising edge of this input defines a triggering event in trigger mode. For details, see section, continuous, and trigger mode. Rec interval, the time interval between records of CSV files. For the trigger mode, I can scan in a 10 milliseconds, bigger or equal than 10 milliseconds. And for continuous mode, bigger or equal to 100 milliseconds. This input defines the period used for sampling inputs values from input 001 to the last one input here, and saving them in CSV files. Comma delimiter, if we are using this type must be true if the defined CSV delimiters using countries like US, it's a comma delimiter, and must be false to define US CSV delimiters used in countries like Brazil. So just a configuration about the file that we are creating. And file header, definition of final part of file reader. This input defines a string with titles for the values columns of CSV files. So how to do this? Is it difficult? Let's explore and simulate a project that I have here. Here, I will reconnect to my network here. So I log out here, just to use in the direct here. Okay, let me just, oh, of course, I'm not connected with the cable. We disconnected when we tested the modem. So let me just rescan here. Okay. So before this training, I create a POU, a subroutine, and let me log out here, just a channel to show you. When I inserted the data logger, of course, I need to insert the library. So I found here the library data logger that is available in the installation, data logger. So I installed this data logger here. And with this data logger, I received this graphical functional block. And I inserted here. I will update the parameters here just to show you all inputs that we have. Of course, for our case here, I just insert 3 parameters. So I will remove unused functional block call parameters. So what do we have here? An enable, data logger enable, the file name. I created the prefix of the file name, Afro. If I'm connecting to a USB or a memory card that we saw, we'll store in the internal memory of the Express. I want 100 file records for each file. The number of the files that I want is 5. I will choose the continuous mode, not the trigger one mode. I want the circular, so I will replace if I choose the circular here and I send the parameter to true, I will replace the oldest one files and I will show you. The rec interval here, it's about the record interval here. It's the 100 milliseconds, and I will not use the comma delimiter here because my Excel is set it from Brazil. And here the file header, you can see here that I put 3 variables, and I just create the file header from the first column, temp, pressure, and manipulated variable. And we will saw this, we will saw in the next session, the PID. And here, just create some variables here to busy, error, status, and so on. So what I will do now is this. Log in again. I'm logging. And I will return here to device, files. Here, I will update. Okay, don't have any message. Log out here. Here. Here I am the root. So I have the internal memory. And inside the internal memory, I don't have anything. What I will do now, it's start to collect information. So I will enable. And here you can see that there is some storage. I choose 105 files. So I will check now. I am in the second one file, and I will check here, updating. Folder data logger, year, month, timestamp, and this is created, and here the CSV file. So I will update again, another one. And you can see that every time I would, sorry, every time I put, I give an update command, a refresh command appears. So I have 5 files here, and I choose 5 files, but I have a 6th one. Why I have a 6th one? Because I have 5 completed files here and 1 in current store. When I give update again, you can see that the first one disappeared. Of course, it was replaced by the 6th file. So this is the circular mode. When this file achieves approximately 4K, at this case, will replace the third one. And now we'll replace the 4th one. Well, how can I check these files? I will just copy these files to a folder here. This is my computer. So I will bring this training here. I will copy this. Let me just update it here. I will copy the none. And now I will here see them after training. I will open this Excel and let's check the information about this file. Here, first point, do you remember the head file, temp, pressure, manipulated variable? Let's return here, temp, pressure, manipulated variable. Do you remember the record? This is the 9. So of course I started from 1. This record start and I ask for 100. So I started at 801 and goes to 900. And I don't have, I just have 100 per file. Actually, here I need to format to HH, and I will put And this I will, okay. So here you can check that is 100 milliseconds, the difference from all storage. And of course, this is the value that I have in each part. Okay. So the difference, it's almost, for everybody, it's 100 milliseconds. And we keep going, replacing. If I return here, update, we are in this file. Okay, any question about the data logger? I will stop here. And when I start here, you will see I restart the system here. So I start again accounting, and inside the device here, let me just, we can see that I created another one file, another one folder, I'm sorry, with other files. And the oldest one file, the oldest one folder has just 5 complete files and 1 interrupt in the middle. Okay? Any question? Okay. Let's take a look at the PID as the last one topic from our session today. Let's take a look at the PID loop controllers and process simulation. So let's talk a little bit about, let's do a briefing about the PID. What is this? This part includes the analysis of some advanced features of the device with regarding the industrial applications, emphasizing the use of the PID function block. Basically, we have the process, industrial process here, and we connect some sensors. It's the plant output variables, and can be sensors, buttons, keys. We send this information to digital and analog inputs, and this information comes to the PLC that is running a loop controller. And we do the calculation inside this functional block and update the analog outputs and digital outputs too. So we have here the plant input variables that are motors, valves, lamps, so mainly the actuators. So seeing this diagram here, we have the sensor, so a temperature transmitter here, sending information to a PLC, temperature controller, and this temperature, this PLC, this functional block PID, updating a TCV, temperature control valve. So it's actuated to, for example, heating a product. Okay, so I measure the temperature of this product, send information to the PLC. The PLC can adjust the control valve, open more or close more, this, updating this information to maintain the temperature that I want, the set point of my temperature. Okay? So, PID, what is the PID? Proportional, the P. Proportional control maintains a linear relationship between the value of the process variable and the position of the final control element. The magnitude of the correction is proportional to the amplitude of the deviation that is The output of the controller is proportional to error. The greater the deviation, the greater the correction of the proportional term. So here we have the controlled variable and the proportional action connecting, sending the information to the field, to the control valve, for example. I, integral term. The purpose of the integral action is to eliminate the permanent deviation left by the proportional action, causing the continuous correction of the output signal until the error is eliminated. The correction is proportional to the integral of the error. As long as there is a deviation, the controller output will increase or decrease, only stopping the variation of the output when the deviation disappears. So here we can see the controlled variable here. I have a step here, and I controlling with an offset. And if I have this error here, the integral action will try to reduce this error, exactly doing the integration of the error and sending this information to the output, of course. The D, derivative. The term derivative introduces a correction action proportional to the speed of variation of the deviation, combined with the proportional action when the process variable departs from the set point. The output varies more than it would only vary with the P or P plus I action. On the other hand, when the variable is returning to its original value, the derivative mode has an opposite action, reducing any oscillation. It can be said that the purpose of derivative action is to decrease the time for correction, the deviation, anticipating correction action. Derivative action is also known as anticipatory action, and anticipation time is called derivative time. So derivative action basically avoid to the systems here give some overshoots, because I'm breaking my output and giving some slow information to my manipulated value or variable. Well, the combination of proportional, integral, and derivative controls actions characterizes the PID controller. This combined action has the individual advantage of each of the three control actions. The equation for such a controller is given by this form. In this equation, Kp is the proportional gain, Ti is the integral time, and Td is the derivative time. Oh, yes, it seems very complicated, because control, it's always a little bit complicated. But what is available to assist us in the industrial process? So we have inside the Express, object trace, and faceplate PID. Some key points here in our PID block. It's the possibility of using the trend, adjustment of variable based on the concept of error, response, Ziegler and Nichols, and the unreset wind up to prevent saturation of the integral. Well, it's how to do this, it's too difficult. Okay, let's explore the same project that I created before here. Here we have the POU that we are using. So I will close the data logger here. Let me stop this one. And let me show you here, close these. Well, to create, first point, to create this PID program, it's total available here. We have the PID control. So I created this. When I create these, I can open this using a structural test editor, too complex, but we are calling the controller and sending some information, configuration about the PID controller. But I will close this because this is too difficult, and I will reopen here using the faceplate. So what we have in the faceplate? We have setting charts here to synchronize. We have information about the set point, the process value, the sensor, and the information that I'm sending to the field, the manipulated variable or value here. The mode of my controller is if it's automatic, reverse, or direct. The information about the SP, PV, MV. The parameters, gain proportional, time integral, and time derivative here. If I have to set, or if I want to set a deadband here, max variable. So I have everything ready here and some push buttons here, some buttons here to exactly to actuate before, for example, I send this information to a SCADA or a HMI or so on. In the advanced settings here, what we have, it's exactly the linearization of my process value, my sensor here. I'm using everything from 0 to 100%. Of course, the set point is blocked because I need to compare the same variables to the process value with the set point. And my manipulated variable here, it's from 0 to 100. Here the sample time, here if I want to direct or reverse, at this case I will reverse because it's better to see in the trend. And here if I want to send some restrictions to the field, for example, if I have an inverter and I want to avoid that the inverter runs a pump less than 20%, for example, I can set here from 20 to 100. So here I open from 0 to 100 from both of these. And let's take a look here. Oh, I'm sorry, let me just return. This is the variable. This free variable I created at this global variable list here, PV, SP, and manipulate variable. So I just connected here. And now I will log in and let's take a look at these variables. So what I have here, I will start the chart here and you will see that the free variables, it's in 50%. So I have my process variable in 50%, I want 50%, and my manipulated variable here, it's in 50%. This is the perfect condition. Of course, the process condition never works like this. That's why we have the PID controller. So I am in manual here, and what I will do now is setting automatic. Okay, the manipulated variable stays at 50. Why? Because I have no error. I have 0 error here. So what I will do, it's insert. I will turn the potentiometer that I have here. This is connected to my analog input. So I will send in information. So you can see here, the red one, 50, 56. And you can see here that it's decreasing. This decreasing is given to us by the integral time, the time integral here. So I will change the signal from the error. I will send in the PV less than the SP. Again, the integral time it's trying to react to this. If I want 50 degrees, for example, and my process variable, it's giving me information that it's 40, of course, they are increasing my valve, open my valve to heat my system. And here you can see I'm doing this process total out of control, but my output always try to react from my input. Okay? To help this, I will send the command to manual here just to show another very nice feature. We can add a trace here. I added this trace before. When I put this, the analog input 0 and the analog input 1, just to show I'm running the processor here. So you can see here, I can put this, and I'm changing the analog input 0, and now I will change the analog input 1. And I can stop here, stop the trace, and insert some cursors here to check, for example, the difference. Cursor number 2. For example, here I have the measure about the green one, for example. It's 20,000, and the second cursor is 16,000, and the difference is this. And when I move this, so I can analyze my process using these features. So to help us with this kind of problems or process that we found in the field, we have these two very nice tools total available in from our basically compact controller and to our most complete, for example, our redundant system. So everything that you saw here, it's available to use. Okay, folks, that was this what I'm planning to show for today. So now we can talk about the presentation, and you can talk. You can do in your questions or comments. We are open to talk. Me and my both colleagues, Mr. Try and Mr. Stout, that is in the room with us.
Yeah, thank you very much, Maurice, for your for your presentation and for these great sessions. It really was very useful, and looking forward to keep connecting with you internationally and locally through AFO in Egypt. Thank you very much.
Yeah. Oh, thank you, Mr. Mohammed.